What is the area of the green triangle? Label points A, B, C, and D. Triangle A, B, C is an isosceles triangle. Let angle A equals theta, which equals to angle C. It is because base angles of isosceles triangle are equal. Also, let the opposite side length be y. Hence, from triangle A, B, D, we use cosine rule for the square of line B, D as shown on the screen. Substitute values and we have that the square of 13 equals the sum of the square of y, and the square of 14 minus 2 times the product of y and 14 times cosine theta. Simplify and make cosine theta the subject of the formula. We have that cosine theta equals the sum of the square of y and 27, all divided by 28 times y. We call it equation 1. It implies that also, from triangle A, B, C, use cosine rule. The square of line B, C equals the sum of the square of line A, B, and the square of line A, C minus 2 times the product of line A, B, and line A, C times cosine theta. Substitute values and we have that the square of y equals the sum of the square of y and the square of 18 minus 2 times the product of y and 18 times cosine theta. Simplify and cosine theta the subject of the formula. Cosine theta equals 9 divided by y. We call it equation 2. Substitute value of equation 2 into equation 1. It follows that 9 divided by y equals the sum of the square of y and 27, all divided by 28 times y. Cross multiply and we have that 9 times the product of 28 and y, all divided by y equals the sum of the square of y and 27. Simplify and combine like terms. It follows that the square of y equals 252 minus 27, which equals 225. Take the square root of the equation. It implies that y equals the square root of 225, which equals 15. Substitute into equation 2. Hence, cosine theta equals 9 divided by 15, which equals to 3 divided by 5. By trigonometric identity, sine theta equals the square root of 1 minus the square of cosine theta. Substitute value of cosine theta. It follows that sine theta equals the square root of 1 minus the square of 3 divided by 5, which equals 4 divided by 5. Hence, the area of green region equals half the product of line A, B, and line A, D times sine theta. Substitute results obtained in the area equation above. The area of the green region equals the product of 15 and 14 times 4. all divided by 2 times 5, which equals 84 in square units. Therefore, the area of green region equals 84 square units.